Hey y'all, welcome back. So today we're solving some more equations involving trigonometric functions. There are a lot of these on the homework are going to be similar to the ones from 3-1, but there will be some that will require some of the techniques that we learned today involving using substitutions or using identities to do substitutions. And we'll also see a couple that have multiple angles. So let's just jump right in here with number one. Now on the first few, like 10 or so problems, or looks like 8, I'll give you a little hint, as far as to help you if you get stuck. Number one, we're going to solve this by collecting our like terms. I'm going to start by adding cosine x to both sides. Let's make that a little smaller here. Make it a little bit easier to read. Nope, doesn't like it. Okay, we're off to a great start here. Okay, that'll work. Okay, so yeah, we're going to add cosine x to both sides. And we also want to put that constant over on the right-hand side. We want to subtract root 3. So I'm also going to put in a minus root 3 here. And I'm going to do that on both sides. So I'm actually doing 2 steps in one here. Okay, so cosine x plus cosine x is going to be 2 cosine x. And then the root 3's will cancel out. And so we get equals, these cancel out, equals negative root 3. Now we want to divide both sides by 2. So I'll divide this side by 2, divide this side by 2. And so I should get cosine x equals root 3 over 2. Okay, so that's going to be what cosine x equals. We still
Right off the bat, we have an error here. And this is just kind of a sloppy error, to be quite honest. When I divided by 2 and I got root 3 over 2, I somehow lost the minus sign, the negative. So let's go ahead and put that back in. So we're not looking for the angles pi over 6 and pi over 11 anymore. And if you look at the unit circle, you can see what the answers really should be. We're looking in quadrants 2 and quadrants 3 because cosine is negative. And so this is going to be at 5 pi over 6 and then 7 pi over 6. So these should be the correct answers.
Let's take a look at number 2. Here we're going to add 3 to both sides. Just to save a little bit of time here, I'm just going to, for the intermediate steps, I'm just going to write like this. I think it just might go a little faster here. Okay, so then when I add 3 to both sides, I get 4 times sine squared theta equals 3. Then I'm going to divide both sides by 4 to give me sine squared theta equals 3/4. Then I'm going to take the square root of both sides to give me sine of theta equals plus or minus. The square root of 3 is the square root of 3. You can't really simplify that, but we can simplify the square root of 4. It's just going to be 2. So we're going to be looking for all the angle measures on the unit circle where the sine value or the y coordinate is plus or minus root 3 over 2. And I just realized I didn't take down my unit circle. Let me move that over here. My bad, y'all. So take a second, pause the video if you need to go back and look at those steps. But what I'm looking for here are the angle measures where the y coordinate is either positive root 3 over 2 or negative root 3 over 2. And I'll hide me for just a second here. The first one that we see is at pi over 6.
All right, so we're off to a pretty rough start here with mistakes on number 1 and number 2. This is the last one, I think, but let me know if you guys find any others. These answers are not correct. It looks like I did is I was pulling the x coordinates, I was pulling the angle measures where the x coordinate was plus or minus root 3 over 2, but I should really be looking at the y coordinate for sine. So these angle measures are not correct. Instead of being pi over 6 and 5 and all these, it should be pi over 3, 2 pi over 3, 4 pi over 3 and 5 pi over 3. And you'll see if you look at the unit circle itself, that at these angle measures, like at pi over 3, for instance, you see the y-coordinate is root 3 over 2. The same thing happens at 2 pi over 3. I don't think you can see my cursor here, but if you look at 2 pi over 3, you'll see that the y-coordinate is root 3 over 2. And then in quadrants 3 and 4, you get the two angle measures that have a y-coordinate of negative 3 pi over 2. So these should be the 4 angle measures between 0 and 2 pi that satisfy the equation, not the ones that I had initially. So yeah, these should be the correct answers.
For number 3, the hint says factor a GCF, but really factoring is only going to be useful when our equation is equal to 0. So we are going to subtract cosine x from both sides, and that will give me 2 cosine x sine x minus cosine x. Now from here, we can see that we've got a common factor. We've got this cosine x on both terms, so we can factor that out, which leaves me with cosine x times 2 sine x minus 1 equals 0. Now we can use the zero product property here and set each factor equal to 0 separately, and then we will solve them. So we can have cosine of x equals 0, or sine of x equals 1/2. So now we're looking on the unit circle for anywhere where cosine is 0, which let's start with that. Let's find out where cosine is 0. If it helps, I'll bring up the unit circle. Of course, now it's in the way. It's always getting in the way. So for cosine to be 0, you would need to be at either pi over 2 or, just copy that, pi over 2 or 3 pi over 2. And then sine is equal to 1/2 at, let's see here, pi over 6. And I think the other one's 5 pi over 6, yep. 5 pi over 6. That's it. So going back, just a reminder, we are trying to find the values that are in this interval. So we don't need to write the plus 2 pi in or find any angle measures that don't lie in that interval. Number 4, we've got to factor it. So out to the side, this is where I like to kind of out to the side rewrite this as like 2x squared minus 3x plus 1 and figure out, okay, well, how would that factor? My first term is 2x squared, so the first two terms must be 2x and x. And then my last term is 1, but the middle term is negative 3x. So I'm going to say minus 1 and minus 1, and that should work. Okay. So here's how that would factor. So we can rearrange this and write it as, I think we actually might have done this one in the notes. Now that I kind of recognize this problem. Maybe we use cosine instead. I don't remember, but I remember the factoring being the same. So yeah, so this should be no big deal since we did this one in the homework, or in the notes rather. 2 sine theta minus 1 would be the first factor, and the second factor is sine theta minus 1. And so just like with the last problem, we can use the zero product property and set each one of these equal to 0 and solve for sine theta. And for the first one, we'll get sine theta equals 1/2, which we already solved over here, number 3, right? We already got those two angles. And then we want to know where sine of theta is 1. So that's going to be at pi over 2. So I'll take these two angle measures for the first one. Say theta equals pi over 6 and 5 pi over 6, which is where sine of theta is 1/2. And then sine of theta is 1 at 3 pi over 2.
Just a really quick correction here. Sine of 3 pi over 2 is definitely not 1. You can see on the unit circle it's going to be negative 1. So the angle measure where sine is equal to 1 should actually be pi over 2. So let's go ahead and make that quick correction, and we'll go back to the video.
Let's take a look at number 5. Number 5, we're starting to get serious here. This is going to be the first one where we use our Pythagorean identities. And so what we want to do is we want to write one of these in terms of either tangent or secant. It doesn't really matter which one you pick, so we'll just pick one. And what we'll do is we will use a Pythagorean identity to, let's say we'll rewrite this one. Okay, so we're going to rewrite secant squared theta. Okay, so when I do that, I get 3. Oh, whoa, whoa, whoa. There we go. 3 times 1 plus tangent squared theta. All right, minus 2 tangent squared theta. Minus 4 equals 0. Okay, so from here, I'm going to distribute my 3. So it'll give me 3 plus, oops, 3 tangent squared theta, and then minus, the rest of this will just stay the same. One thing I'll need to do here is, oh, that's weird. I didn't copy the whole thing. Is we need to put this in our sort of standard quadratic form. So what I want to do is I'm going to combine my like terms, which are these two and these two, and I'm noticing I don't have like just a tangent. So I'm going to solve this using square roots once I get there. So 3 tangent squared theta minus 2 tangent squared theta is just going to be 1 tangent squared theta. And that will equal 4 minus 3 is 1. So we get tangent squared theta equals 1. Okay, so from here, we need to take the square root of both sides, and we get tangent of theta equals plus or minus 1. So we're looking for all the angle measures where theta is either positive or negative 1. And hopefully by now you know where those are going to be. If not, no big deal. You can pull out your unit circle and figure it out. It's going away. Okay, come on. All I want is a theta. Don't make it complicated. Okay, there we go. So theta equals, it's going to be all the pi over 4s, okay? Because at pi over 4, tangent is 1. At 3 pi over 4, tangent is negative 1. At 5 pi over 4, it's back to positive 1. And 7 pi over 4 would be negative 1. But since we're looking for both positive and negative 1, we will get all 4 of those solutions. Number 6, kind of similar to one that we did in the notes, where we need to square both sides. And so when I do that, what I'm going to get is sine squared x plus 2 sine x plus 1 equals cosine x, cosine squared x. Again, I'm getting that from squaring both sides. So I'm squaring this side, and I'm squaring this side. So for the left side, I'm going to factor that, and it will factor pretty easily. Sine x plus 1 is actually the same as both of these. You know what? I might not even have to do that. I'm gonna step back for just a second, and I'm noticing I have a cosine squared x here. So I'm gonna rewrite that as 1 minus sine squared x using that Pythagorean identity, similar to how I did at number 5. Let's see what happens, because this might actually clean up a little nicer. 1 minus sine squared. Or maybe not. Yeah. Either way, it's good that we did it now. So I'm going to subtract 1 from both sides, and we'll actually cancel out both of these 1s. And then I'm going to add sine squared x to both sides, so I get 2 sine squared x plus 2 sine x equals 0. From here, I can factor out the GCF, which is going to be 2 sine x, and I'll be left with sine x plus 1. And I could set each one of these equal to 0. So I get either sine of x equals 0 or sine of x equals negative 1. Now, we'll be almost done here. You know, sine of x equals 0 when x is, I guess that would be 0 and pi. And then sine of x is negative 1 at 3 pi over 2. So, but what we need to do since we squared both sides is you've got to remember to check your solutions for any potential extraneous solutions. This is something you don't really have to worry about most of the time. But when you square both sides, it can happen. So anytime you square both sides, you have to make sure to go back and check your work. So I'm just going to plug this in. Sine of, so let's just say, okay, so if x, we'll do one for 0, we'll do one for pi, and we'll do one for 3 pi over 2. Okay, so for 0, sine of 0 is, let's see, sine of 0 would be 0. So we have 0 plus 1 equals cosine of 0, which is 1, so that checks out. For pi, we've got sine of pi, which is 0 plus 1 equals cosine of pi, which is negative 1. That does not check out. So we know this one right here is no good. The pi. And then finally for 3 pi over 2, sine of 3 pi over 2 is going to be 1, right? Sine of 3 pi, oh no, it's going to be negative 1. Sine of 3 pi over 2 is negative 1, plus 1 is 0, and then cosine of 3 pi over 2 is 0. So we got negative 1 plus 1. Does that equal cosine of 3 pi over 2, which is 0? And yes, it does. So we just have these two solutions, and pi is not going to be a solution. So I just might make a note here that this pi is extraneous. Might be better off just typing it out, actually. It's what we call an extraneous solution. It's a solution that arises out of the normal solving process, but that actually isn't a solution. And again, you do not have to worry about extraneous solutions unless you square both sides, at least for today. All right, let's take a look at number 7. This one's hint is to don't divide until after you find the angles. So that's because we've got something going on the inside of the parentheses. So the first thing we want to do is we want to add root 3 over 2 to both sides. So we get sine 2x equals root 3 over 2. And so, you know, the hint here is saying, hey, don't divide yet. Okay, we're going to wait until we actually find our angles. So sine of what angle is 3 pi over 2? I'll bring this up. You know, I don't have to bring this up every time, but every once in a while it's good to throw it up here. But we're looking for an angle measure where sine is equal to root 3 over 2. And I see that happens at pi over 3 and 2 pi over 3. So what we're going to say here is actually that 2x equals, what was it, pi over 3 and 2 pi over 3. And so if I want to find my actual angles, I need to divide by 2, but I'm going to do that last. So if I divide everything by 2, I get pi over 3. Well, divide that by 2, and you get pi over 6. Yeah, all those other ones. Okay. And then 2 pi over 3 would reduce to, let's get rid of this. 2 pi over 3 divided by 2 would be 2 pi over 6. Which would simplify, okay? 2 over 6 would be 1 over 3. Now, this would normally be it, but there are going to be other solutions. Remember, we're going to, like, if we were talking about the general solution here, we would write it like this. X equals, you know, just exactly what we had, but we would say, you know, normally we would say plus 2 pi n, but since we divided by 2, it's actually going to be plus pi n. And the reason I'm bringing this up is because that means our solutions are going to be separated by pi units. And if we're trying to find all the solutions between 0 and 2 pi, we have to find like the solutions from that next cycle. So we're going to add pi to each one of these. So pi plus pi over 6 would be 7 pi over 6. And then 2 pi over 3, I'm sorry, pi over 3, pi over 3 plus pi would be 4 pi over 3. Gosh, it took me a long trip to get there. And so here are going to be your 4 solutions. Now the first 2 are the only 2 on the first cycle, but because we've got that horizontal compression, we actually have 2 cycles between 0 and 2 pi. So you want to make sure you grab these, is I guess what I'm trying to get at. Okay, number 8. Here, it looks like we need to subtract 6 from both sides, and then we're probably going to end up factoring this. So tangent squared theta plus 5 tangent theta minus 6 equals 0. This is going to be a factoring problem. So out to the side, I'm going to write, 4x squared plus 5x minus 6. Try to figure out how in the world to factor this. It's going to be some guessing and checking here. So I'm going to start with the 2 first terms being 2x and 2x. I don't know that for a fact. It could be 1x and 4x, but I'll sort of exhaust my options here and see if I can't get it right. So for negative 6, the sum has to be positive, so I want the bigger number to be positive. So I'm going to try plus 3 and minus 2. Guys, this is just a guess. It's probably not going to be right. But that's how I figure this out, okay? So 2x times 3 would be 6x, and then minus 4x. Okay, this sum is not even close to 5x. It's positive 2x, so we know this is not correct. I wonder if we don't actually want to use 4x and x. I'm trying to think here. Let's see. So we got 2 and 3. Yeah, I'm thinking we go 4x and x instead of 2x, 2x. Let's at least try it. See what happens here. So here we got negative 2x okay, negative 2 times x, and then, well, 12, that definitely is not going to work. But I wonder if we swap the 2 and the 3, if that will work. So I'm going to try minus 2, x plus 3. Oh wait, that's what I had before. Let's try that again. Plus 3, and then x minus 2. And you never know. I mean, this probably won't work either. We're basically going to keep trying it until we get one that works. So we got 3x, and we got negative 8x. Okay, we're getting close here, because this would add up to be negative 5x. We're real close. So it looks like what we got to do here is let's try to switch the signs, make the 3 negative, the 2 positive, and I think we're going to be there because this is going to be negative 3x, it's going to be positive 8x, and it does add up to 5x, so we've got our factors. Whew. Now, you'll saw me go through like 3 or 4 different checks here, and I didn't have the answer like memorized or anything. I just, I know we've got to try a couple different combinations until we get it right. Just don't get discouraged if you don't get it right on the first or second try. Just keep moving terms around, and you can figure it out. So here we're going to have, so now that we know the factors, we've got 4 times tangent theta. Almost. Okay, 4 tangent of theta minus 3 is going to be one factor, and then the next factor will be tangent theta plus 2. All right, so this whole thing's going to equal 0, and I'm going to start getting my solutions. Now, we're going to get, if we use the zero product property, we get tangent of theta equals 3/4. This is not going to be something on the unit circle. And we also got tangent of theta equals negative 2. Neither of these are going to be on the unit circle, unfortunately. So what we want to do is we want to use inverse functions. Oh, goodness. Unit circle, you're in my way. Oh, Lordy. All right, it's all good. It's all good. Just take a minute. Pause the video if you have to again. Sorry guys, I gotta be more on top of that, make sure that unit circle's not in the way. Maybe we should just leave it off from now on. You got your own unit circle. I think I'm gonna just stop bringing it back up because it's blocking too much stuff. Now I'm wondering, how much did I actually block here? Well, no sense worrying about it too much. We'll just continue on here. Again, I apologize, y'all. So basically, where I want to get to with all this is that if you get something that's not on the unit circle, then you're going to have to use inverse functions. Now, you're going to want to say like theta equals the inverse tangent of 3/4, but like we talked about in class, that's not going to be the only solution we get from there. Because the period of tangent is pi, we're going to get a whole nother solution between 0 and 2 pi. And to get that other solution, we're going to add pi. Okay, so like for this one, we have whatever this is, plus pi. Where's plus pi? There we go. Okay, and then for the second one, we're going to do basically the same thing here, where we have the inverse tangent of -2. Now let's be careful here, okay? Because I believe this is going to give me a negative. Let's throw this in the calculator, see what happens here. Okay, just make sure that we're getting the right ones. So inverse tangent. Let's first make sure we're in radians. Yep, we're all good there. So we got the inverse tangent of 3/4. Should be like points, I don't remember exactly, but maybe 1 point something. Oh, okay, so 0.64 radians. Okay, so that's a little more than half a radian. So we're talking like 40 degrees or something like that. And then if I add pi, I think that won't have any issues there. The reason why I wanted to check this first is because this one right here, I don't believe is going to be in between 0 and 2 pi. Let's check. So like if I'm giving rounded answers, I would say, theta equals approximately, instead of exactly, what did I get for that? 0.644, and then we also got 3.785. Can I have a space in there? Doesn't like the space. Well, that could work. Just to get a little space in there. So we got, okay, so we got 0.644, 3.785, but if I do inverse tangent of a negative, it's going to give me a negative radian. Let's see here. So this is not going to be in between 0 and 2 pi, because 0 and all the numbers between 0 and 2 pi are positive. So we still have to add pi here, but that's only going to give us like the first solution in the correct interval. So we're going to add pi here. To get the second one, we need to add pi again. And hopefully we're not too big. Remember, 1 full revolution is 2 pi. So if we get bigger than 6.28-ish, then we're not going to list it. But we're going to add pi here. Oops. Okay, so we get 5.176. So the first one, we'll get, let's delete all this. Just trying to force some spaces in there. I don't know why it's giving me such a hard time about that. Yeah, so we're going to have to add pi to this one, which is what this will equal. And what did we get? We got 2.034. And then the last one, we're going to add pi again. Let me just hide this real quick so you can see what I'm writing down here. There we go. And then the last one will be inverse tangent of -2 plus pi, and then add pi again would be plus 2 pi. So kind of, you got to really look at these decimals to make sure that you're looking at the right one. This is something we might go into more detail with next time. But anyway, so our last one, let's bring that back up, is going to be 5.176. Okay, so these are going to be our exact answers. You can see what a mess that is. And then here are the rounded answers. Okay, so here's the exact and rounded. Trying to make that fit. That's good enough. I wonder if I can just browse it, move that over a little bit. There we go. Okay, so that one was quite the problem. Okay, hopefully we don't have too many of those because that, this whole inverse function is a little tricky. All right, so starting with number 9, no more hints here. So we have to figure out, problem by problem how we're going to solve these. So with this number 9, I'm going to start by factoring out a cosecant x, and that'll leave me with secant x plus root 2 equals 0. Then I'm going to set each one of these equal to 0. So cosecant x equals 0, which actually never happens. So that one's not going to result in any solutions. And we can see on the unit circle, why that may be the case. And over here we get secant of x equals negative root 2. So let's go ahead and rewrite this one. So the problem here is, what's the reciprocal of 0? It's undefined. So this one's not going to produce any solutions over here. But this one over here should, okay? Because if I reciprocate both sides, what I get is cosine of x equals the reciprocal of root 2, which is 1 over root 2. And if I were to rationalize that, I would get root 2 over 2. So I'm looking to find where is cosine positive root 2 over 2. I'm sorry, negative root 2 over 2, my bad. Got a little ahead of myself there. So yeah, where is cosine equal to negative root 2 over 2? And that's going to be at 3 pi over 4 and 5 pi over 4. Okay. Number 10, what we have to do is use one of our Pythagorean identities to rewrite cosine squared as sine squared. So cosine squared theta equals 1 minus sine squared theta. And then we have a plus sine theta equals 1. We could subtract 1 from either side, and that's going to leave me with really everything else, because the 1 on both sides will cancel each other out. They'll equal 1 once we combine them. So we get negative sine squared theta plus sine theta equals 0. From here, I can factor out sine theta as a GCF and be left with negative sine theta plus 1. From here, I can go ahead and split this up and get either sine theta equals 0, or, copy. Having some trouble copying and pasting over here. Sine of theta equals 0, and then over here, if I subtract 1, divide by negative 1, I would get sine of theta equals 1. So we're looking for all the angle measures where sine of theta is equal 0 or 1, and so we'll say theta equals 0, pi over 2, and pi. And I'm not going to list 2 pi here because that is not in the range of acceptable answers here. Remember, we're only looking for answers between 0 and 2 pi. We can include 0, but not 2 pi. We're thinking of 2 pi as like the beginning of that second cycle. All right, number 11. We've got this multiple angle here, so we're going to actually find our angle measures first and then divide by 3x. So I've got 3x equals, the places where tangent equals 1 is going to be at pi over 4 and 5 pi over 4. I got to be careful with my solutions here. In fact, I know I'm only supposed to give between 0 and 2 pi, but it might be helpful if we write out all of them first, okay? Just to make sure that we collect all the ones that we're supposed to. So if I am supposed to multiply, if I'm supposed to divide everything here by 3, what I get is x equals, well, pi over 12. And let's see, divided by 3 would be 5 pi over 12. And if I divide this by 3 as well, I get plus 2/3 pi n, or 2 pi over 3. So that means I'm actually going to have, well, 3 more sets of, like, there's going to be a total of 3 cycles that will be in between 0 and 2 pi. So what I need to do is I need to add 2 pi over 3 to both of these to get the solutions on the second cycle, and then add it again to get the solutions on the third cycle. All of those would be solutions in between 0 and 2 pi. So these are the first two. If I add 2 pi over 3 to both of those, now 2 pi over 3 is going to be, let's see, if I need a common denominator, that would be times 4, 8 pi over 12. Okay, so if I add 8 pi over 12, I'm going to get 9 pi over 12 and 13 pi over 12. And if I add 2 pi over 3 again, or 8 pi over 12, I'll get the last two that'll be in our expected range here. Let's see, 8 pi over 12 plus 8 plus 9 would be 17 pi over 12. And then 13 plus 8 is 21. 24 pi over 12, by the way, would be 2 pi. So that if we go past 24 pi over 12, then we've gone too far. But these would be all the solutions between 0 and 2 pi. For number 12, looks like we're going to, what are we going to do here? You know what? I think we can use a reciprocal identity here. Write this as 1 over sine theta, or sine x. So let's see what happens when we do that. We got 2 sine x plus 1 equals 1 over sine x. And then if we multiply everything by sine x, we're going to get 2 sine squared x, plus sine x equals 1. So we want to subtract the 1 from both sides. And now we can factor, okay? So these will factor as 2 sine x. Let's see, this would be minus 1. And then sine x plus 1 equals 0. So we get x equals, sine x equals 1/2, or sine of x equals -1. Let's clean that up. Let's move these over a little bit. And so we'll get our final answers here. We got x equals, let's see, so where's sine of x 1/2? That would be at pi over 6 and 5 pi over 6. And then sine of x is -1 at 3 pi over 2. Okay, well, we're doing all right here. Let's take a look at number 13. All right, number 13, it looks like we're going to have to use one of our Pythagorean identities again. We'll rewrite. It doesn't really matter which one we pick here, so let's go ahead and pick the secant squared. So according to our Pythagorean identities, secant squared theta is equal to 1 plus tangent squared theta. Okay, then we have plus 3 tangent squared theta. Ah. Copy and paste has not been my friend today. Okay, equals 0. So we're going to clean this up. Factor. Y'all know the drill here. Okay, so I'm going to distribute the 2. That'll be 2 plus 2 tangent squared theta. Plus 3, and then the rest of this should just be the same. So I just wanted to do that distributive property first. Okay, now I'm going to combine, and so I'll get 5. Ugh, is this going to be gross? Okay, let's hope we can factor this without too much trouble. 5 tangent theta, at least 5 is prime, so that shouldn't be too bad. Oh, actually, we're not going to have to factor anything here. We can just solve this with square roots. Oh, thank goodness. So I'm going to add 1 and divide by 5, and so I'm going to get tangent square theta equals 1/5, and then I'm going to take the square root of both sides and get tangent of theta equals plus or minus 1 over root 5, which let's see, if I were to rationalize that, I would multiply it by root 5 over root 5, so get root 5 over 5. So yeah, this is gonna be an inverse problem. So not a big deal. It's just our answer is going to look pretty ugly here. All right, so let's try to break this down. We're going to have a total of 4 solutions here. We're going to have theta equals inverse tangent. Just to make this a little bit readable, I'm just going to list them vertically here. Inverse tangent of root 5 over 5, so that'll be 1. Okay. We're also going to get that thing plus pi. So this number. And you can throw this in the calculator if you want to get a decimal equivalent. Not really necessary though. And then for the negative root 5 over 5, I've got to be careful. Anytime I do inverse tangent of a negative, it's going to give me a negative radian measure. So just like we saw on, let's see, what problem number was that? Number 8, we're going to have to add pi twice to get like within the correct range here. So we're going to say plus pi for the first one, and then for the second one, we'll add 2 pi. So we get a total of 4 solutions here. Oh no. Goodness. Okay. No big deal. Try to stay positive here. Not sure why I'm struggling so much with this today. This video is probably twice as long as it needs to be, but we'll get it done. Okay, so let's put a comma after this, and then minus plus pi. And then this one should be plus 2 pi. All right, oh gosh, what a crazy list of solutions here. Yikes. Oof. All right, number 14. Well, both of these are squared, so we can just use, we could do a direct application of the Pythagorean identity here. So we could rewrite, for instance, cosine squared as 1 minus sine squared. So let's start with that. So sine squared theta equals 3 times 1 minus sine squared theta. And then we are going to distribute the 3. So far, so good. Nothing too crazy like the last one. Equals 3 minus 3 sine squared theta. Okay. Now we're going to add 3 sine theta to both sides, which will give me 4 sine squared theta. equals 3. I'll divide both sides by 4. And then take the square root of both sides. So I'll get, okay, sine of theta equals the square root of 3 over the square root of 4, which is 2. And I need to remember, make sure to get that plus or minus. Okay, so this is going to be kind of a basic one compared to some of the more complicated ones we've seen. So here theta will equal every angle measure where sine is positive or negative root 3 over 2. So let's bring up that unit circle. And we could see that that's going to happen at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all 4 of those pi over 3s. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay. Yeah, I mean, relative to some of the other ones, this one's not that bad. Let's look at 15. We've got 4 more left here. With number 15, what I'm going to do is I'm actually going to rewrite this tangent as sine over cosine. Let's see what happens. So I get cosine of x plus sine of x times sine of x divided by cosine x. So what it's kind of looking like we're going to need to do here is it looks like we're going to need to multiply this by this. We're going to need to find a common denominator to add them. And then I'm not really sure what to do after that, but we'll see. So we got sine squared x over cosine x. Okay, so basically I just multiplied those two functions together. And then I do want a common denominator so that I can actually add these two terms together. So this needs to be over cosine. So I'm going to multiply this one by cosine over cosine, which gives me cosine squared x over cosine. Now I've got a common denominator, so I can add these two fractions together. So I have cosine squared x plus sine squared x. What happened there? There we go. All over cosine x. And that will equal 2. Okay. Now we do have a Pythagorean identity that says that if you have sine squared plus cosine squared, that equals 1. So we get 1 over cosine x equals 2. So if we reciprocate both sides, I will end up with cosine x equals 1/2. And everything kind of cleans up nicely there. And now we can find our angle measures. So we've got x equals all the places where cosine is 1/2. So bring this guy back up, and I can see it's going to happen at pi over 3 and 5 pi over 3. All right, only 2 solutions for that one. Okay, number 16. So for number 16, it's already set up. There's not really like a lot for us to do. We just need to actually find the angle measures. So you're going to say 2 theta equals all the places where cosine's 1/2. So that's going to be at pi over 3 and 5 pi over 3. Actually, we just solved that one on the last one. So that's kind of nice. But that's where 2 theta is. We want to know where is theta. Now, this is going to have the same issue as some of those other ones where we're going to have more angle measures that end up falling in our correct, in the domain we've, or the range that we've, domain that we've selected. So just to make sure I grab all the correct ones, I'm going to say plus 2 pi n here. and then I'll divide everything by 2, and what you'll see is that causes a horizontal shrink on our function so that our period becomes pi instead of 2 pi, which means that we're going to have 2 more solutions that we otherwise would have. So dividing everything by 2 gives me 5 pi over 6, 5 pi over 6. This will do plus pi n. So if I'm going to write all the solutions that are in between 0 and 2 pi, it's going to be these two, and then we're going to have 2 more on the second cycle because we'll have 2 cycles in between 0 and 2 pi. So that would be plus pi would be 7 pi over 6 and 11 pi over 6. Very tricky. Oh my gosh, that did it again. Why does it do that? Gosh, that's so annoying. All right. All right, well, just to go over the solutions again, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, you better not delete on me this time. There we go. All right, we got 2 more here. Number 17 looks like a factoring problem. So we're gonna, out to the side, I'm gonna write 2x squared minus 7x plus 3, and I'm gonna think about how I'm gonna factor that. If I can write, there we go. Okay, so the first 2 terms have got to be x and 2x if they're gonna multiply to give me 2x squared. So I'm gonna say one is 2x, the other's x. And then if this is 3, it's got to be minus 1 minus 3. This one's actually not so bad. And then I can check, this is negative 6x minus 1x is negative 7x, so that works out. So the factoring here will be, hide that, there we go, 2 times the sine of theta minus 1 times sine of theta minus 3. I'm actually going to erase all this so I have enough room to do what I want to do here. Go on, get out, go away. I've had enough of you. All right. Well, didn't get it all, but that's good enough. Okay, now once I've got my 2 factors, let me just double check, yeah, all looks good. Then we're going to set each one equal to 0 and solve them individually. So I got sine of theta equals 1/2. And I have sine of theta equals 3. That should throw up a red flag. Sine of theta equals 3. Yeah, sine of theta is never going to be 3 because the range of sine is -1 to 1. So this is never going to happen, so we're going to get no solutions out of this guy. But we will get some solutions out of here. So theta equals, I want to think, where's sine equal to 1/2? It's going to be at pi over 6 and 5 pi over 6. All right, last problem here, number 18. We're going to solve it very similar to 16, except we're probably going to get a ton of solutions since we're going to have to divide everything by 4. So we'll get 4 groups of solutions here. Well, actually, it probably won't be too bad because we want to see where it's equal to 1. So first, first things first, let's find where is sine equal to 1. So sine is equal to 1 at pi over 2. And then if we're writing this, in the general form, which it can be helpful for this kind of a problem because we're going to end up getting multiple solutions here. So this would be how you would write it if you were asked for all of the solutions. Then you would divide everything by 4. And so you get theta equals, well, pi over 8 plus 2 divided by 4 is 1/2. So pi over 2n. So basically, if I add pi over 2, I'm going to get another solution. And so that means I'm going to end up with 4 solutions. I'm going to end up with pi over 8 as the first one. And then if I add pi, half pi, it'd be like adding 4 pi over 8. That gives me 5 pi over 8. And then if I add another 4 pi over 8, that gives me 9 pi over 8. And one last one, if I add another 4, that gives me 13 pi over 8. And all of those are going to be in between 0 and 2 pi. All right, whew, this homework. Goodness gracious. I don't even know how long this video is, but I know it's going to be long. Hopefully y'all stuck with me. If you have any questions, just know that these are some of the hardest, I'll just say the hardest problems, equations you're going to solve, this year. Okay, there's definitely some really tough ones and a lot of nuance here to remember with like the extraneous solutions, making sure, this whole like inverse function thing gets taken care of properly. When you've got multiple angles, you might end up with more solutions than you might expect. And there's just a lot going on here. Okay, so practice, practice, practice. You will get better. As always, let me know if you guys have questions, and I'll see you next time.